Thanks, Jack.
Gotcha.
All right, so we're just going back through this first practice one from yesterday. So if you've already done it, you're good. But I thought it'd be worthwhile. Like, why do you think we're doing step 2? If the plan is to figure out how far away, like most of these numbers are, well, like think about what that does. What's up, Daniel? Yes.
I made a critical mistake.
That's all good. That's why it's coverage. Well, I'm happy for like 30 or 80.
I got a golf triangle there. It's double-ended.
So, I mean, I said this yesterday in class, but it probably wouldn't have stuck unless you were here. Like, I mean, think about it. Like, Tyson, how far are we away from each other? We just guess in feet. 10 feet. All right, Chandler, how far away do you think we are from each other, me and you? Okay, so if we're 10 feet, me and Tyson, and me and Chandler are 15, how far away are you two from each other? The difference between them, right? 15 minus 10. That's what step 3 is trying to do, is figure out how far away these numbers, so in that value spot, 8, 4, 6, 6, 7, 7, 9, 4, 8, 5. What they want us to do is subtract to find the difference, to find how far away that 6.4 is. That's why we're doing this step. I want to know how far away each of my numbers are from the other. And think about it. The more spread out the numbers are, the bigger all those numbers are going to be. The closer together those numbers are, the smaller all those numbers are going to be. And that's what standard deviation is going to do. Super small number, numbers are closer together. Really big number, numbers are far apart. Standard deviation, to deviate, to be different, right? That's all we're trying to do. So let's do it. We got some repeats, so we don't necessarily have to do all of them one by one, because then we can just copy them down once we see it. Which we have to do each one. 8 minus 6.4, 4 minus 6. We have to do every single one. So help me out. Type some stuff into a calculator. It's pretty simple. I picked an easy one because the numbers are pretty small.
1.6.
1.6. Do we have any other 8s? Yep. Second one from the bottom, so there's another 1.6. 7 minus 6.4, not 0.64. 0.6. I thought you said 0.36. Negative, so 0.6 for the 7s, okay. What was that, Pete, the 4s? Negative 2.4. Okay, there's another 4, negative 2.4. Negative 1.4. Okay.
Negative 0.4.
Negative. And I like to put the 0 up front for anything that's got no number on the other side of that decimal. This reminds me that it's there. 2.6. Okay. I know it's going to cover it up a little bit, but step 3 done. Subtract each value from the mean. So all those numbers in green tell us how far away each one is from the average. Now, obviously, people way, way smarter than me figured out this was a good next couple of steps. We're going to take all of those green numbers. We're going to square them. Then we'll add them up and take the square root. Okay, so we're going to square them. It'll get rid of the negative. It's going to change the number. We'll add them up, and then we'll take the square root eventually. Something like that, okay? So what we need to do now, and I'll switch back to a new color. I got to take all of those green numbers and multiply them by themselves. It's like 1.6 times 1.6. Negative 2.4 times itself. 0.4 times itself. 0.6 times itself. All of our numbers should end up being positive because we're multiplying numbers by themselves. Positive times a positive, still positive. Negative times a positive. goes negative times a negative back to positive. So I need some help. 1.6. 2.56. Okay, 2.56. So there's another one down here, 2.56. The 2.4 squared, 5.76. We have another 4. Yeah, 5.76. Yeah. And here's how I do some of these smaller ones in my head. So 0.4 squared, look, what's 4 squared? 16. Oh, in the decimals? Okay, just keep it in the decimals. Like, oh, 6 squared is 36. Oh, 0.6 squared? Okay, then 0.36. I just keep it in the decimal. 2.6 squared, that's too big for me. I don't know what that is. Man, it's 2.6, 6.76. Cool. And then this should be 1.96. Because 14 squared is 196. Okay. Now, I know I'm all in the way. Number 5, add them up. All your blue numbers on that right-hand side, add them all up. I'm going to do it. My calculator to make my life easy. Being really careful that I put the decimals in the right spot. I don't mess up. Let's see if we get to the same spot. All right, count them up, find the average, find the difference, square it, add them up. So I don't really even need like the bottom part right here. Like that sum isn't necessary. It's just the sum of the squares. Anybody get anything yet? All those blue numbers added up? Nice, me too. 26.4. Okay, that is a super important number for us. Because that goes right there. Okay, the variance is that 26.4 divided by not 10, not just n, just one less than that. And by taking one away, it kind of takes up some of the error that might have happened along the way, like if we get rounded, if one of those numbers kind of stood out more than the others, if we had any outliers. So I'm not going to divide by 10, I'm going to divide by 9. I got to press equals, so I get 26.4. Divide by 9. So we can round, that's fine. Usually I'll round when the repetition starts. Like I'll stop at the first 3. That's enough. And we looked at this yesterday. The difference between me keeping all the 3s and me leaving just 1 3 was almost nothing. There was like almost no difference. Now we take the square root of that number. Whatever that is. This is where, if you're on your phone, you got to turn sideways. Square root 2.93. 1.7. Now it's going to start going all over the place because it's irrational. So I think rounding to just 1, maybe 2 decimals is plenty. Like 1 right there is enough. And so what is that 1.7? That is how spread out the data is. Basically, and you'll see this here today, maybe tomorrow. I'm going to give you tomorrow's handout, by the way, so you have it at home. I will see how far we get today, but also, what time are we done? What time are we out of here today? 11:17. Okay, I have it somewhere. Here, yeah, 11:17. Perfect. Okay, so we still have a half. 20 minutes. So 1.7, really small, right? That means the data is pretty close together. And look at your numbers: 8, 4, 6, 6, 7, 7. Like, compare all those numbers to 6.4. All those numbers are really close. Now, imagine these were the 10 numbers. 7, 7, 7, 7, 7, 7, 7, 7, 7, 7. Is there any difference between any of those numbers? Standard deviation is 0. Literally no difference in the numbers. They're all the same. But something like 7, 7, 7, 7, 7, 7, 7, 7, 7, 6. All really close together, but one of them's off. It's going to have a standard deviation, but it's going to be super tiny, like 0 point something. But if your numbers are like 9, 30, 4, 106, 11, 9,000, 46, -3, standard deviation is huge because your numbers are all over the place. And that's what that number is trying to get us to do. See how spread out all these numbers. Okay, that's the plan. That's the idea. Cool. Okay. You can finish that at your convenience day, tomorrow, this weekend. I just want to at least get us started on this so that tomorrow makes a little bit of sense. But did that help seeing it again? Okay, good. That's the idea. I want to make a little bit more sense than it might have. All right, so folks at home, you got this from me yesterday, right at the beginning of class. I said we're going to use it tomorrow. Here it is. Today is tomorrow.
I'm going to take this real quick.
Yes. Let me go full screen anyway. Oh, you know what I'll do? I'll use the. I don't know why it's gonna ask me. Good. All right. Now, this whole chapter, like this whole unit, is all based on the kind of the relationship between, all right, what is your average? What's your mean? And what's your standard deviation? Like, where's your middle? Like, what's the average between all your numbers? And how spread out are they? And when there's a certain kind of data set, data that is normally distributed, and that is a capital N normal, okay? Normal distributions. And so there's some blank spots in there so you can fill them all in as we go, okay? They have that same shape. And I know we talked about that a little bit at the end of chapter 1. We started to talk about, like, all right, how do I, like, draw that density curve, right? Like, was there like 2 humps or 3, or was it right skewed? Was it left skewed? Or our favorite, was it normal? Okay, they're symmetric. There's one peak, and they are bell shaped, which is why we call them a bell curve. And a lot of data is normally distributed. Especially data with more points in it. The more points you have, the more normal the distribution gets. And I'm going to show you something cool. Sometime in the next couple of days, like, so much stuff happens that's normal. It's actually pretty fun to watch. And so, like I said, it's all about the average now, the mean, okay? And we use the Greek letter mu. Okay? This is like a U, but it's got like a tail on the front. So I like go up and then down. So it looks like there's a U. It's just got like this piece on the front that comes down a little bit further. Okay. And then from last time, standard deviation, this one, like an O with like a little top. Why do we use Greek letters for everything? Well, math started way before America did. Yes, my man. Ooh, that looks beautiful. It's going up on my wall. Thank you. Gorgeous. Tell Warren Burton I said thank you. All right. I'm going to sand it, stain it, put it up in the sun's or measures heights. Okay, so that's the only thing that matters. Where's the middle and how spread out is everything? Okay, so we're going to look at mu and we're going to look at sigma, the mean and standard deviation. Okay, now sometimes we just say, here's the mean, here's the standard deviation. We just say that, but sometimes we use this notation. Capital N for normal, and we'll write them in that order. The mean first, and then the standard deviation second. Just don't have to write the words. Mathematicians were lazy. There's a reason why I teach math, not the great English papers. Math is a whole lot faster, a whole lot easier to read if we've got a way to write it. Okay? So that notation will come up sometimes, and you can always just refer back to it, but it's always like, where's the middle, and then how spread out should I go? Okay? The mean is always going to be in the middle, so it's the center of that symmetric curve. The standard deviation gives you an idea of how wide that curve should go. And this is a lot more obvious, I think, with the colors than it is on your black and white copy. Like the difference between the green one, the purple one, and the red one. What's the average for all three of those? 10, which is why the center is in the exact same spot. But look at how spread out the data is. A standard deviation of 1 versus 2 versus 3. Okay, the more spread out the data is, meaning the bigger the standard deviation, literally the more spread out the curve. Okay, it has to be flatter to do that. Okay, and what I want us to start doing, what we're going to get good at, is sketching these bell curves and marking off how these things go. Okay, the center will always be the average. So right in that spot below that first dotted line for number 1, put the 95. Now it's hard to draw these things perfectly by hand, but we're going to try. The idea is to try to draw them symmetric and just have that one single curve kind of right in the middle. And what each of these tick marks do, both to the right and to the left, is it takes us one standard deviation above and one below. And then 2 above and 2 below and 3 above and 3 below. Okay, so we're going to have the average in the middle, and then to the right, we're going to go up each time by the standard deviation. 95, 100, 105, and 1. Same thing below. 95, 90, 85, and 8. And that's pretty easy to do because the numbers are nice and easy. I don't need a calculator to help me add and subtract 5 from numbers like that. And we'll talk about in lesson 3, this is just like we're trying to figure out what these bell curves look like, what all of that means, and how we can figure out what's going on. Because as we build, you're going to see this entire unit. It's all about that. Normal distribution only. And eventually we'll get to a final project that we'll find some normal data, and we'll, like last time you didn't pick on any like specific point. Like I know somebody did there's a lot of really interesting ones. Thank you guys for all that work. They're really cool. One that I really liked was looking at poverty rates kind of across the country, in which state has what kind of poverty rate, what percentage of their population was below the poverty line. But it was just like, okay, here's all the data, right? With this, we can start picking on individual spots and seeing what's going on. All right, so the mean is always in the middle. And if they write it like this, there's your average, there's the mean, there's mu, there's your standard deviation. There's sigma. So the middle is always that first number, 23.8. And then just every tick mark above it, just keep adding whatever sigma is, whatever your standard deviation is. Now, decimal, so 23.8 plus 5.2. 29. Plus 5.2 again. 34.2. Plus 5.2 again. 39. And then I back it up. And I subtract 5.2. What was it? 23.8 minus 5.2. 18.6 minus 5.2. 13.4 minus 5.2. And you'll see what's going to happen with this bell curve and why all of that is helpful for us to do. Because eventually what we'll do is we'll say, oh, hey, there's you right there. Like you actually were number 29. What does that tell about you compared to everybody else? And we'll actually look at what that does. We just got to get good at drawing these bell curves. That's 2. All right, turn to the back. Go ahead.
Rosie, can you go back up to 1 really quick?
Yeah, let me rewrite it.
Oh, wait, never mind. It's fine.
Well, sorry, well, I'll do it though. It's okay. 95 is the middle, right? Mean is 95. And this tells me how much up and down I got to go every tick mark. So 95 plus 5 plus 5 plus 5. 95 minus 5. 95, 90, 85, 80. Right, so your average always goes right there. And you start adding it. We're going to, so like this one is like mu plus sigma. This is mu plus 2 sigma. This is mu plus 2 sigma. Just keep adding. Turn to the back. Knock it out.
Thank you.
You're welcome. I'll do it as well so you can see that if you're getting them right. First couple are pretty easy. They drew the curve for us. And then like for 6, 7, and 8, you're going to try to actually draw that shape. Like you have some blank space there on number 6. The idea is to see if you can draw it out. So here's the middle, 100. Okay. Add 15, add 15, add 15. Subtract 15, subtract 15, subtract 15. Okay. It's a pretty simple setup if you know what you're doing. Start in the middle, put your number. Add 1 every time and subtract 1 every time. Right, add 15 or subtract 15, add 6, subtract 6. Calculator to help if you need it. Nothing wrong with that. Some of the numbers are kind of big, like number 5, average is 676, and then you got to add 60 every time. So you don't have to write your numbers side by side. Let me show you a strategy that a lot of people like to use for something like number 5. They either switch colors, so it's more obvious which one's which. 736, 616, and so on like that. You just switch colors if you've got some colors. Or turn it sideways. 676, 736, 796, 856, and on down. And then you get to try to practice doing this. Got to make sure that the middle is where the top is. And if it's not symmetric and you don't like it, do it again. You have pencils. But being perfect is really hard. So you just got to draw the line for yourselves where you think perfection is. That's pretty good. Something like that. Nice to draw that dotted line so you feel really good about where you're moving. And that's it. That's lesson 2. That's not too bad, though. They're not going to be perfect. Mine's not perfect, for sure. I just think back to the day where I drew a really nice density curve and Maddie gave me some props. Like, from home, she shouted me out. Dude, that made my day. It made my whole freaking day. No, that's what I need, a bigger head, right? Last 45 seconds or so. Oh, wait, no, what time? 13 or 17? 17. Oh, we got 5 minutes. Oh, we got plenty of time. We should be able to easily knock this out, though, which is awesome. I love doing that. If we can get all of this done, then we can just turn the page tomorrow to lesson 3 that I think I gave you out, right? You guys got? I haven't given it to you yet. So I gave you lesson 2. Let me give you tomorrow's. Yeah, I thought about that. Listen, and seriously, unit 2, all of it, normal distribution. We're going to see these bell curves a lot. So here's tomorrow. Tomorrow. What do you mean? Better than mine. Which one's your best one? I think. Now, I came back here at the beginning of class and there were 2 left. And there's still 2 left? How'd you do that? Like, I have no. Oh, while you're talking about these, you go from the right. You like went to the left at the top and then masked it? Okay, so you're good, you're good. You're good. I like that one. That one's good. Like having like that little like it kind of like starts slowly and then jumps up. Nice. I like it. I like it. We got 3-something minutes. These are good. Folks at home, is there anything you want to see? Like any of these problems you want to make sure you're getting right?
Could I see number 4 again, Mr.
Number 4, sure.
Thank you.
Yeah, so let me actually, I don't think I've done it yet. I got to put an assignment on Canvas for lesson 2. Let's do that real quick. Sure, if it's done, let's just get it in now. You don't have to worry about remembering to do it later. Lesson 2, submit here, 5 points, unit 2, online, file uploads. I put it in myself. It is due today, Thursday. Save and publish. And then I'll go back to number 4. Let me drop it into the module real quick. No, front and back. Yeah, whatever we do, I like to see it all. Why not? Where are you, though? I wanna. Oh, it's because it's probably sitting. It's in there. It's in unit 2. Modules. Is it somewhere else? Where are you at? Weird. Yeah, lesson 2. I don't know why it's not showing up. Why don't you let me put it in here? I don't know. It's under assignments. Unit 2, lesson 2. I don't know why it's not letting me get it in there, but let me do number 4.
What if we're done, Ryan?
That's for you to keep. Put it on Canvas so I can take it from there. Where am I at? No, there we go. Number 4. So the average is 60, so that goes in the middle. Standard deviation is 6. I'm just going to go up 6 every time. 66, 72, 78. And then down 6, 54, 48, 42. 5. Bam. Easy, right? Sweet.
Yeah,
Easy,
perfect.
good. I like easy. Simple idea that we can get complex with. Now we get it. All right, I'm going to stop recording because I think we're good. So folks at home, remember, I got to see you guys tomorrow. You guys are back in school tomorrow. We'll do lesson 3. I'll hook you up with the piece of paper.